On behalf of Phoenix Integration, welcome and thank you for joining us for today's webinar presentation entitled MBSE Ecosystem, System and Analytical Models Integration for Critical Systems Simulation. Today's webinar will be presented by Dr. Andy Ko, Phoenix Integration. Andy has 13 years of experience, 4 of which have been with Phoenix Integration. He currently serves as the Engineering Service Manager. His duties include managing the production team working on commercial and government projects, research project management, application engineering, proposal writing, and sales support. He interfaces with many of Phoenix Integration's customers, including JPL, Lockheed Martin, U.S. Army RDEC, Honda R&D, and DARPA. Before joining Phoenix Integration, Andy was Director of Engineering Services at Avid LLC. At Avid LLC, he has served as Project Manager and Technical Lead for aircraft design and analysis projects. Dr. Ko has also served as an adjunct faculty member at Virginia Tech, teaching both senior aircraft design courses as well as basic aerospace engineering material. He has also taught short courses to industry on UAV design. Dr. Ko has received numerous collegiate awards, as well as Best Technical Paper at AIAA's 2007 Modeling and Simulation Technologies Conference. He is an active member of AIAA, serving in leadership roles on the Multidisciplinary Design and Optimization Technical Committee. This presentation will run approximately 45 minutes long. Following the presentation, we will open the floor to questions. To ask your question, please use the Q&A feature in your WebEx window. We recommend that you view the webinar in full screen. To do so, please click the down arrow in the lower right-hand corner of your screen, scroll to View, and select Fit to Viewer. We are also recording this presentation today, and you will be notified via email once the video is available for download from Phoenix Integration's website. So I'm sure many of you have been to see the symphony orchestra at one time or another, and if you have, you may have wondered why the conductor gets so much attention. When the conductor enters, there's a lot of applause, and everyone really focuses on the conductor. And it's certainly not because the conductor is going to play any musical instrument, and the conductor isn't there to teach people in the orchestra how to play either. These people have spent their lives becoming experts on their instruments, but I think we all understand the conductor is important because the conductor is coordinating the activities of all these people. A good conductor can make all the difference. The conductor not only chooses what is going to be played, but makes sure everyone plays it with the same interpretation, and that everyone is listening to one another and is coordinated with one another. If it's done right, the end result is a lot more than what you would expect, even with all those expert musicians on stage. So what if you had a conductor for your engineering organization? Someone who could coordinate all the different software tools that your team uses, and someone who can help keep track of all the data and help everyone collaborate and stay in sync. So that's exactly what Model Center does. Model Center is not an analysis tool, so it doesn't do thermal analysis or structural analysis. Model Center is the framework to help you get the most out of your engineering activities. So if we look at the components of Model Center, there are really 3 main pieces. The first piece is Model Center Integrate. And Model Center Integrate just drives productivity because that's the piece that will allow you to take any software tool that you or your team is using, automate the individual software tools, but more importantly, tie them all together across the network if needed into an automated workflow so you can run your analysis all automatically in one sweep instead of having to do everything manually. So that's Model Center Integrate. And once you're able to tie your software together into these automated workflows, Model Center Explore comes in, and that helps you drive innovation. Because what Explore does is it lets you run that simulation over and over again with different inputs. And it really unleashes creativity because it allows the engineers to go in and focus on being engineers instead of writing scripts and worrying about mundane details like that. There are algorithms that help you search the design space, and algorithms that help you view and ask what-if questions about the design space. And then the last piece is Model Center Organize, which helps to drive collaboration. It helps you to capture all the data that these workflows are created. It helps you share that data with your colleagues, and it helps you keep track of what that data is to avoid having to do the same thing over and over again. So those are the main aspects of Model Center. And looking at the next slide, you can see an example of a lot of the organizations that are using either one or all of those different aspects of Model Center. Today, we'd also like to thank our webinar partners, NoMagic and AGI. And now it's my pleasure to introduce Dr. Andy Ko, who will be presenting the webinar today. Andy?
Thank you, Carl. So let me start sharing my screen. Okay. So let me just start by talking about the bridge of a ship. Over on the left-hand side, you can see the communication system on an old ship, or the bridge of a ship. And on the bridge of a ship, in the olden days, the ships would have tubes running all throughout the ship. And for the captain to communicate to any member of that ship, he'd have to look at the right tube, shout into the tube, and hope that the person on the other end is listening. Now you can see how this is difficult. Today's present ship is a lot more easier. We have modern communication devices, and there's not a lot of shouting back and forth. The captain has access to all the information he needs at all times, and the two-way communication with the crew is easy. Now, what if today there exists a similar challenge in communication between systems engineers who steer product development and the designers who actually implement and realize that vision? So what if you could communicate, or you could connect these two worlds such that they both communicate seamlessly, not only in terms of the engineers talking to each other, but also their models? What if you could give systems engineers the ability to accurately estimate the performance of a system early in the development process? Now, if this was possible, it would mean greater confidence in the architecture of a system at the beginning of the project, improving your chances of staying on schedule, being within budget, while at the same time producing superior products. Well, we do have a solution for that, and that is MBSE Model Center MBSE Pack for Phoenix integration. Now, before I continue, let me introduce myself. My name is Andy Ko. I'm the Engineering Services Manager at Phoenix Integration. I've been with the company for about 4 years, so a little over 4 years, and have been doing model-based systems engineering, MBSE, during this time. Before Phoenix Integration, I was very heavily involved in the UAV industry, doing design and testing of UAVs. I know the design process very well during those years. I have a PhD in aerospace engineering from Virginia Tech, specializing in aircraft design optimization. So let's continue here and talk about Model Center MBSE Pack and why you need it. So what's the problem? Why do we need to address this, the need to have good communication between systems engineering or systems engineers and domain engineers? Well, as our technologies advance, as we get more and more products, the complexity of those products increases. And there are a lot of inefficiencies when we have more and more complex products. Let's take an example of an assessment done by the U.S. Government Accountability Office in 2008. Now, this report that came out from the GAO in 2008 says the average schedule delays in government projects of 21 months with an budget overrun of 26%. Now, this is a lot of money. It comes up to about $295 billion, up from $42 billion just 7 years earlier. That's a lot of money. There's a common belief that simulation in the development process, right from the very start when the systems engineering work is being done, can help in reducing this schedule delay and budget overruns. Now, the National Science Foundation issued a report that said that simulation is a key element for achieving progress in engineering and science. We cannot hope to understand, develop, or utilize these technologies without simulation. So it is clear to us that simulation early in the design process is important, and getting that merged together in the design process early on when systems engineering is done is important. But how do we bring that simulation into the design process? How can it be done in an organized and structured manner? Now, systems engineering design or systems design has a process for this, and most of us who are systems engineers know this. It's called the V process. And really the V process is what we've been doing. That's the traditional design paradigm, where design and development happens on the left-hand side. So it starts off with a concept, and teams go through the requirements and work through that through the subsystem design, the detailed design, and analysis. And once they're done, they start doing the implementation, going up the right-hand side of the V, doing tests, subsystem tests, integration out to the product. During the right-hand side effort, that validation is being done, between the different levels. Now, that's the traditional V process. However, how does simulation actually affect this V process? What we've found is that with simulation, you essentially are creating smaller Vs within the V itself. Within the bigger process, you have smaller Vs where compliance and validation happens throughout the process, continually looking at the design, continually validating it, continually running through, using simulation to look at the design such that there's less waste, there are fewer mistakes that happen. So by the time we get to the last part of the V, the implementation, everything, hopefully, most of the issues have been worked out. Now, how, obviously, we know that's done through software. We have simulation software, so early on we use systems engineering software such as Magic Draw, Doors to capture requirements. We use mathematic tools like Maple and Matlab, use simulation tools like STK and Simulink. We go through the CAD process and use FEA and CFD to look at flow physics and material physics. All of that is being done during those small little V's that we talked about. And then what we do is we use Model Center, as Carl just mentioned, to integrate all these tools together such that they talk to each other. Now, how specifically, though, does the integration happen between the systems engineering and these tools, instead of just being individual pieces on their own, having to be manually run by engineers? Now, let me give you an analogy before I get to that. And the analogy is of the city of Chicago. Have you ever wondered how the city of Chicago came to become such a major city? Did you know that it was shipping that the city first got its start? Now, if you look at the state of Illinois, and I have a map up here, the Mississippi River runs on the western side of the state. Lake Michigan is on the northeast part of that state. Now, lots of shipping happens on the Great Lakes area, on Lake Michigan, and there's a lot of shipping that happens on the Mississippi River. Now, in 1848, the state of Illinois started building a waterway, and that waterway connected Lake Michigan with the Mississippi River. Now, once the waterway, and this waterway is long, it's about over 300 miles long worth of waterways. Now, once this was completed, shipping and goods coming from the north, from the lakes region, can access the Mississippi River and get goods bring goods all the way down to the Gulf region in New Orleans. And any materials and goods from New Orleans can go up north and access through this waterway up to Lake Michigan. And guess what? What city lies at the mouth of that waterway? That's Chicago. So that is how Chicago became such a great city. The same analogy applies with the gap between model-based systems engineering and domain engineering. Currently, MBSE, or model-based systems engineering, is descriptive in nature, while domain engineering is analytic in nature. If we can connect the two, MBSE now becomes not only descriptive, but also analytic. Then you have consistency of information. You can react to requirements faster and more consistently, and we can improve collaboration between systems engineers and domain engineers. We do that through MBSE Pack, through a tool within MBSE Pack called MBSu Analyzer. So over on the left-hand side, in this slide, you have the systems engineering, the architectural models, the requirements happens on the left-hand side. Over on the right-hand side, we have analysis models created in Model Center. It could be SDK, a CAD software, Matlab or Maple that can be executed. In the middle, we have MBSu Analyzer that connects the two, that takes values and value properties from systems engineering and can execute them in the domain engineering role and bring that information back. As requirements change, we can reanalyze and look at what its impacts are. Now, I can talk about it, but I think it's the best way to kind of see what's going on is actually to give you a demonstration. So let me pull up a systems engineering model, and we have basically an example of a satellite. This is a CubeSat satellite specifically doing the RAX mission, or the Aurora Explorer mission. Now, the mission is captured, or that mission is captured in systems engineering using a magic draw tool in the Sysml language. Now, we have a block definition diagram that shows you what the structure of that mission is. So we have got the CubeSat mission that comprises of things like the vehicle, the ground network, its orbit, the external environment. We can drill down into that vehicle and look at the different pieces of the CubeSat. And each of these pieces have things called value properties that quantify its properties. So for example, in the solar array, I have things like its thickness, the mass density, the areas of the panels on the CubeSat itself. Now, this is the CubeSat itself, and we also have parametric diagrams that links these value properties to analyses. So in this case, our parametric diagram has value properties from the orbit and the vehicle connected to what we call a constraint block that comprises of the SDK tool from AGI and Matlab. Now, let me show you what that external tool is, or what the SDK tool is. And so let me run SDK. Here you go. Now, this basically simulates the orbit of the satellite as it goes around. There are a couple of ground stations, and it looks at its orbit and also simulates when it downloads and uploads information. Also, when it gets sunlight to charge its solar panels. So we have an analysis here, and I can run it. We also have Matlab analysis that we can run. Now that's all connected through this parametric diagram. Now once you've created this, we can actually use MBSE Analyzer to run it. So MBSE Analyzer opens. All I have to do is click Evaluate Designs, and then go to that parametric that we need. In fact, I'm going to run all the parametrics that's associated with this model. So we have get states, which is what you saw, and I have a number of other parametrics. And when I update variables, you see all the value properties all the value properties that is similar to what we have in a magic draw. So you've got you can change parameters such as its orbit, the properties of the ground network. We can do that. Now, once you change that, I can run this. I forgot to mention that we have a column called new, which is its values. And what it does is, when I hit run, it takes the values, goes through MBSE Pack, runs it in Model Center, gets the output. So we see STK running. I'm going to minimize this. You'll also see Matlab running in the background. It runs that through Model Center, brings the results back, and gives you results over here. And we have up and down arrows to show how the outputs change from the original value. And from there, I can either save it back to the system model, or I can save it as a particular design if I'd like. Now, so that's how we can connect the analysis model with the systems model. Now, I can also export this model and create a model center model of this entire process such that we can pass it to the domain engineer such that that engineer can run it and make changes to it and save it back into the system such that everything's updated. So that's essentially how that connection happens. Let's go back to the presentation. So Plato said that the beginning is the most important part of the work. Now, this is true in the systems engineering world. Getting things right early means avoiding expensive rework later on. The Department of Transportation, in its report in 2007, said late changes drive up the cost. So if you can see, if you start making changes later on in the process, it drives up costs. So you want to fix things right at the start. In addition to that, most requirement changes happen at the start. That's where we're trying to flesh out those requirements. Now, I've got the Dilbert cartoon here, which is kind of funny, where, requirements keep changing. Well, yeah, and I'm not going to tell you what those changes are. Now, as funny as this is, this happens in real life. Now, MBSE Pack and systems engineering and combining these analysis can solve these problems early on by letting engineers do architectural trades and also show you some requirements verification. So let me just demonstrate those two aspects of those two pieces here right now. Now, MBSE Pack can do requirements verification by using the Sysml diagram to help it. So now I have, let me find a requirement. So what we've done is we've captured a few requirements for this CubeSat satellite in a requirements diagram. So we've got things like requirements on the vehicle, on its volume, requirements on its operations, on the experiment, on the data storage. All of those are captured in a requirements diagram. Now, you could capture that in a tool such as DOORS, like a requirements capture tool. Those can be synced down back to the Sysml diagram and be represented here. So it doesn't mean that you have to do everything in the Sysml diagram. Now, once we've done that, we can link those value properties that are being calculated with this requirement such that we check it. So I've got a requirements verification diagram that illustrates how this works. So we use something called the satisfy relationship, where we link this requirement with a value property. For example, for vehicle weight, we might have a text that says the vehicle shall weigh less than 3 kilograms. Now, we connect that to actually the total mass of the vehicle through the satisfy relationship. We also add something called an upper bound. So it's a tag on that requirement that reflects the value of that 3 kilograms over here, and that's an upper bound. So when we run the analysis, MBSE Pack will automatically look for the satisfy relationship, take this mass, compare it with that upper bound, and say, did you meet it or did you not? Let me demonstrate. So I'm going to open up MBSE Analyzer again, and remember this MBSE Analyzer window. I can go ahead and change one of the parameters, let's just change, say, the apogee altitude. I'm just going to move it up to 820. And it's shown that that value has increased, and run it. And new values come into being. As you can see, over on the right-hand side, you'll see this column called margin. And what this margin is actually doing is it's telling you how much margin you have from the requirements that was in the satisfy relationship. For example, we have the energy lower limit. It's met its requirement over 4,000 joules margin. Let's look at, say, for example, the buffer. It's met its requirement. Now, when the requirements change, I can go ahead and change those requirements in my requirements diagram, change that upper limit or lower limit, rerun this, and we can see how that requirement affects the design. We can then go ahead and change the design to kind of meet those requirements if it doesn't. Now, you can do this over and over again, then save it out as a design point, or save it back to the Sysml diagram. Now, one can do this manually, or you can run things like a parametric sweep or a DOE. So a design of experiments, we can run different cases and try and hone in on the right design. We can do architectural trades that way. So that's how we can do requirements verification. I did talk about architectural trades, and I just wanted to show you one aspect of what we offer in terms of architectural trades. Now, it's a feature called the parts catalog. Now, sometimes most systems aren't designed completely from the ground up. We use COTS parts that come from other vendors, or we have certain parameters that limit our choices. So, for example, let me go down to the solar array. So the solar array might use different kinds of solar panels of different sizes. That could be stored in a database. So what I've done is I've created a database of solar choices, if might you say, in Excel. We could try other databases, and so you've got different array types and different configurations with different solar efficiencies and different areas of those solar panels on the satellite. Now we can bring this in to the system and view it through a parts catalog, such that once I connect that, when I open this up in MBSE pack, and I go up to the solar array, I can either select solar array itself and change the values in here to whatever I want, or I can select those configurations. So I can do configuration C. It would update those values based on that catalog, run it, and see what happens. Now you can see the strength in this architectural trade, because now I can have different choices, and I can run a design of experiments based on those choices and actually look at my real result. And so that's one aspect of that architectural trade that MBSE can provide you early in that design process to discover designs that meet your ever-changing requirements. Now, that is MBSE pack in a nutshell, but there's one more thing I wanted to show you, and that is how we can run behavioral diagrams through MBSE pack and actually run analysis through behavioral diagrams. So I'm going to close our MBSE pack and show you a behavioral diagram and a state machine. Within Sysml, we can model behaviors of systems and put them in things like state machine diagrams and activity diagrams, just to simulate these behaviors. Now No Magic, within Magic Draw, has a tool called Cameo Simulation Toolkit that actually walks through and simulates this behavioral diagram. What we've done with MBSE Pack is we've enhanced it, enhanced Cameo Simulation Toolkit, such that now some of the activities in this activity diagram can also call analysis. So now you can walk through behaviors, and as it gets to the activity that requires an analysis that you've connected to it, it would run that analysis and collect the results. So let me give you an example. Right here, we've got the behavior of the CubeSat as it orbits the Earth, and there's a section of this activity called Update States. And these update states in these three activities, actually they call certain parametric diagrams to do certain tasks and certain analysis. I am going to run this simulation and show it to you in action. So right now it's running, and if I can get to requirements, CubeSat. So what you see here is the state diagram that it's running, and it's running update states, and it's going over here. It went through this CubeSat mission, and it's doing this call MBSE Analyzer. You can see at the bottom, SDK is running, and I'm going to try and speed the simulation up so that you can see some of it. But it's running SDK, it's generating results. If you notice back there, Matlab came on, and the results for the first time step just appeared, and you can see it going through the different activities and stepping through the different activities and stopping at the sections where we need analysis, runs the analysis, goes ahead and updates that, and then it will populate this table of values that comes up from MBSE Analyzer. So I can run this until a stop state, where the state is complete, it completes its orbit, collect the results, plot the results, and look at what happens in the behavior of the satellite. Now that's very powerful, because now not only am I looking at a point design, but I'm also capturing the behavior and simulating the behavior at the same time. Now that's just kind of a taste of what MBSE Pack can do, and it's already, as we look at it, it's a powerful tool combining both systems engineering, making it executable by bringing in the analysis. From the domain engineering side, one can export this model, and the domain engineers can take that and run it themselves, make changes, and bring it back. And that's a very powerful tool, bringing the two worlds together. So, in summary, let me just go back and summarize what we've talked about. I've showed you the executable behavioral simulation by running MBSE Pack through Cameo Simulation Toolkit. We've talked about verification and trades early in the design process, looking at requirements. And I link that to Plato's quote. We've looked at MBSE Pack and how it links MBSE with analysis, just like how the waterways linked Lake Michigan with the Mississippi River. We looked at systems design in the development process and how that relates to the V process, creating smaller Vs in that V process by bringing simulation. And all that is done through Model Center MBSE Pack. So what do you think?
Excellent. Thank you very much, Andy. That was a wonderful presentation. So now we'll move to the Q&A portion of our presentation today. As a reminder, please use the Q&A feature in your WebEx window and not the chat feature to ask your questions. Also, please be sure to send your questions to all panelists. You will not be able to see your question once it's been submitted, but please be assured we will try to address as many questions as possible today. If we're unable to get to your question, or if you have additional questions following the presentation, please do not hesitate to contact us, and we'll be happy to follow up. So for the Q&A section, again, please use the Q&A feature on your WebEx screen. It looks like we've got the first couple questions coming in already, and we will do our best to get to as many of these as we can. Let's see. First question here, what analysis tools does your solution support? What tools can I connect to my Magic Draw model?
To answer that question, just about any analysis tool that you can wrap within Model Center. So we are not limited, nor are we partial to any particular analysis tool. I think that is one of our strengths of our products. As long as you have a way of interacting with that tool outside, say, GUI. So think of it as if you can change a file, an input file or an output file, we can wrap that. If the tool has an API such that we can communicate with that tool, we can do that. So far we have wrapped, I would say, hundreds and thousands of tools, and our customers have at least, and with no problems. Those tools can be combined into different workflows, such that can then be in a single package and then made available in the systems engineering world. So there's really not very much limit. There are very few limitations, let's just say that, to the tools that you can wrap.
Okay, excellent. Thank you. Let's see. Next question here. Andy, is there a tutorial that discusses in details the steps that you outlined in this presentation to conduct the different analyses with MBSE Pack?
Yes, there is. So when you purchase MBSE Pack as a package, there are two things that you can do. We offer a training course, which is the one that I would suggest you do, because it's a hands-on communication with the instructor, and we can work through the problem. So we have a course, and tutorials go with that course. In addition to that, the user's guide that comes with MBSE Pack has a couple of exercises that you can do that shows some of these capabilities and walks you through these capabilities. In addition to that, we have a world-class customer service support staff that you can call after you've done the training if you have any questions that we will be happy to answer.
Okay, great. And let's see, we've got two questions here about versions that I think I can answer. We have the question, what versions of Magic Draw and Model Center are compatible with MBSE Pack, and what is the latest version of MBSE Pack? The latest version of MBSE Pack is version 2.2, and the supported versions of Magic Draw are 17.0.2, 17.0.5, 18.0, and 18.1. Let's see, next question coming in. For the executable behavior analysis, are attribute values pulled from blocks? How are they related to the behavior? Can attribute values be associated with specific activities or actions?
Yes, so those value properties are taken from the blocks. So the blocks contain those value properties, and when you run the simulation, essentially what ChemU Simulation Toolkit does is it captures the state of the starting state or the initial state of those blocks. You can set those initial states, and then it tracks that state as it moves through the activities. Now, once you get to an activity, you can access those value properties through certain other activities that you create inside the Sysml tool or Magic Draw, and then our analysis can operate on those value properties as it moves along to another activity. The changed value properties gets preserved, and therefore it is consistent throughout that behavior. At the end of the activity, what you get out is the compilation or the result of all those activities working on those value properties where it's needed.
Okay. Let's see. Question, are you currently supporting or planning to support MBSE tools other than MagicDraw. And yes, IBM Rational Rhapsody is also supported by MBSE Pack. Next question coming in here, is there any way to view more than one scenario in the table view, sort of side by side?
The answer is yes, but not side by side in the sense that you have the values side by side in the same table. Whenever we run an analysis or run a DOE, we create a new table, and you can put those tables side by side. So if you have a second behavioral simulation that you ran, we'd open up a second table that you can then look at those tables. The issue become if we combine the two, the resulting issue would be a confusion between which columns belong to which simulation. So by doing two tables, you can look at them side by side. So yes, we do.
Okay, great. And another question, so it looks like you created all your MagicDraw models in Sysml.
That is correct. We do also support UPDM, but only because UPDM can be combined with Sysml through the L2 compliance. But yes, we connect right now in MBSE Pack or in MBSE. We connect through Sysml.
Okay, great. Next question. Many system engineers are not proficient with Sysml syntax. Can you comment on the learning curve for integrating analysis tools like Matlab into the Model Center framework?
Can you repeat that question again, please?
Certainly. Many system engineers are not proficient with Sysml syntax. Can you comment on the learning curve for integrating analysis tools like Matlab into the Model Center framework?
So I believe that question is two-layered. Let me answer the second part of it, which is integrating the models into the Model Center framework. That is actually fairly easy. There isn't a big learning curve to it. It's designed to be very user-friendly. It's designed to be easy to use and easy to wrap tools and bring tools like MATLAB, Excel, CAD tools into Model Center and wrap that. In addition, we also offer training courses that will walk you through that process and go through various scenarios of bringing those tools in if you need to. We have good documentation that you also can look at and work through that. So that's the first part. I think it's quite easy to wrap tools and bring tools into the Model Center process. The second part is a little bit loaded, which refers to was it easy for me to learn Sysml? Now, I came from the domain engineering world, and the biggest hiccup for me in learning Sysml is understanding that Sysml is descriptive in nature and not analytical. The paradigm that for me personally that I worked with was everything was analytical. You needed to run something and execute it. And I did not understand for a while how Sysml worked because I was working under that presumption. Once I got over that presumption or realized that that was a wrong presumption or assumption, it was easier to understand that Sysml is a language and it is descriptive in nature. I would strongly encourage, if you're systems engineering, you do not know Sysml, or you're not, you are exploring model-based systems engineering, to take a course or to look at it in terms of an integrated fashion and what benefits it can bring you, especially in terms of consistency and also in terms of traceability. That to me was the biggest thing that opened my eyes to the model-based systems engineering world and how powerful it is.
Okay, great. Another one of our participants says, good morning and thanks for the webinar. I would like to know how easy is the integration between MBSE Pack and STK? Do I have to code something for linking them?
Actually, you do not. So AGI, who are the makers of SDK, have what we call a plugin into our Model Center framework. So all you need to do is get that plugin, install it, bring it into Model Center, and it's a straight drag and drop into the tool and open up your SDK model, and then you have access to all your parameters in SDK. It is actually quite easy to bring it into the model framework just because of this plugin that is fully it's supported by AGI and it works very well.
Okay, great. Can you explain the differences between Model Center, MBSE Pack, and MBSE Analyzer?
That is a very good question. So our flagship product is Model Center. What Carl explained to you with the packages of the different levels of Model Center, that's our flagship product. And that's the part that integrates the tools, the engineering analysis tools together. So if you have tools such as Excel or a CAD tool, FEA tool, you can bring that into the Model Center framework and link the outputs from one tool to the inputs of another tool, and you can string these up into what we call workflows, and you can run them automatically, so that now you can enter values at the beginning. It would flow through that workflow and give you the results at the end. That is the Model Center tool. MBSE Pack is an add-on product that we have available to link Sysml from tools such as Magic Draw with those workflows that I just explained. So that MBSE Pack is the complete product suite. MBSE Analyzer is part of MBSE Pack that gives you the link that I just showed you. Now, MBSE Pack has more than that, more tools than that. I only showed you the important part or one portion of that suite of tools in MBSE Pack. One of the other tools in MBSE Pack that is the plugin in Model Center itself. What I didn't show you is the domain engineer can open up Model Center and use the Magic Draw plugin or Rhapsody plugin, bring it in, and actually access value properties from the systems model without having to know Sysml. So that's another piece of the tools that is in MBSE Pack. MBSE Analyzer is but one of them. So that's the difference between Model Center, MBSE Pack, and then MBSE Analyzer, which is part of MBSE Pack.
Okay, great. Next question coming in for trade studies. How do you handle the information on the different options being explored in order to do comparisons of the results, such as for 5 different options?
So what we can do there is when you run a different option and you find a different option, what the engineer or the systems engineer can do is he can save it back as an instance property, as an instance design in the Sysml tool itself. So, for example, in this satellite, if I found 5 different designs, I could save it as design A, design B, and design C as instances. And then within the Sysml tool, I can look at the slots that are in those instances and compare and look at those differences. So you can do that separately through Magic Draw, and Magic Draw has tools that lets you look at the different designs. On the other side, on the domain engineering side, we can save the different instances and designs, and we have tools over there to actually look at different designs and compare different designs in a table. For me to demonstrate that would take a little bit of time from this webinar. So we can follow up with you on that one and show you how to do it.
Okay, excellent. Let's see, next question coming in here. What are some examples of critical defense and aerospace systems developed and deployed using MBSE Pack, and I can answer that one. We've had some previous webinars presented by Northrop Grumman and Lockheed where they've talked about some of their activities. However, we're not at liberty to discuss customer use of the tools in any more detail without their permission. Next question coming in. How many users can work together at the same time on a given project? Is there a mechanism to make sure there are no conflicts between modifications?
That's a very good question. That is, again, that's two layers. We have to answer that from the Sysml side and also from the domain engineering side. From the Sysml side, I believe NoMagic has a tool, an enterprise tool that allows you to check in and check out Sysml models, and that's a collaboration tool that they continue to work on. And so, yes, for teams of systems engineers working on the Sysml model, there is a solution that NoMagic provides. On the domain engineering side, on the Model Center side, we also have a tool called Model Center Organize, which organizes and helps you version control in a central location your models, the data that you generate through those models, and also designs. It was created specifically to address the issue of multiple data, a lot of data coming in, and a lot of people using it. So yes, on both sides we have tools and we have solutions for making sure things are consistent within teams.
Okay, great. Thanks, Andy. And lots of good questions still coming in here. I think I've got two here that I can answer. Next one coming in are SpaceX and OneWeb considering or using MBSE Pack for their planned large constellations of Earth satellites. Similar to another question I answered, we are talking to a number of different customers looking at using MBSE Pack, but we can't say any more than that. Next question coming in, is there a similar plugin for Matlab like SDK? And yes, Model Center does include a Matlab plugin as part of Model Center. Next question coming in, are there specific formats required to utilize MBSE Pack's interface to the analysis tools? For example, can I embed an M file in my Magic Draw model that gets executed in Matlab via the MBSE Pack, or do I need additional info to execute?
In that case, I would actually suggest that you keep, in that scenario, you keep all the analysis in the Model Center side and all the systems engineering on the Magic Draw side. So in this case, it would be easy to integrate Matlab into Model Center and have that run in Model Center. And in Sysml and NoMagic's Magic Draw, you would just have the Sysml. Now, to connect the two is easy through MBSE Analyzer. I'm assuming you're asking, what if you had Matlab embedded inside or running inside Magic Draw? Would that also be able to connect to Model Center? I don't see why not. However, the coordination, MBSE Pack does not coordinate any analysis that's done directly inside Magic Draw. So in that case, if you have Matlab inside Magic Draw and you also have MBSE Pack, it's actually better for you to kind of integrate that into Model Center. That way it gives you good separation between your analysis tool and your Sysml tool so that you can maintain it well. And also consistency in terms of how you do things. I can see how confusion will happen if you've got analysis that's embedded inside your Sysml tool, say equations, and maybe a Matlab script running in Sysml, and have other tools running in Model Center. That might be a little bit confusing. So while I think it should work, I would not recommend it.
Okay, great. Next question coming in. We've got time just for one or two more here. Next question coming in, is there a planned update to MBSE Pack for later versions of Magic Draw? And at this time, we can't support every version, although we are working closely with No Magic to improve the supported versions here. And we do expect to support a new version of Magic Draw early next year. Next question, is it possible to integrate some sort of optimization, such as genetic algorithm, into the presented design methodology?
The answer is yes, and I did not have time to show that demonstration, but yes. So what we do in that case is we'll take an initial start design from Sysml, we'll export the model into Model Center and do the optimization inside Model Center itself. Now, Model Center has over 30 optimization algorithms, including genetic and swarm, that you can then run that same model. So the same model that ran in MBSE Analyzer can be exported and can be run in Model Center. You can run the optimization, wrap an optimization around it, run it, get the design you want, and then you can actually bring the results and connect it back into through MBSE Analyzer, send it back through Sysml. Now, we do not have optimization algorithms within MBSE Analyzer itself, but through the process of exporting it to Model Center, you have access to those tools.
All right, excellent. Thank you, Andy. And it looks like we're running out of time here. We appreciate all the excellent questions that have been coming in. And if we were unable to get to your question today, we will attempt to follow up with those folks that asked questions we weren't able to get to. And if you think of any other questions, certainly feel free to reach out to us, and we'd be happy to continue the conversation. Also, we'd like to invite everybody to join us for our next webinar next month entitled Analysis and Parametric Assessment of Hypersonic Research Vehicle Design Reference Missions, presented by Kevin Feld of SpaceWorks Enterprises. That webinar will be on Thursday, October 19th, 2016 at 2 p.m. Eastern Time. Once this webinar has been made available to be watched later, we will put it up on our website, and we also have an archive of past webinars available on the Phoenix Integration website. We'd also like to, again, thank our webinar partners, No Magic and AGI, and thank you, Dr. Andy Ko, for the excellent presentation, and thank you for everyone who joined us today for the webinar. Thanks again for your interest in Phoenix Integration, and have a wonderful day.